Hi everybody, this video is about completing the square. What I want to do here is take a closer look where I do a few less tricks and really get into what are we doing as we use this process. When we are given a quadratic equation, we generally try factoring as our approach to solving. But what happens if we can't factor the equation? We can't force an equation to factor, but we can force it into a form that we can solve using the square root method. We can only use the square root method when the coefficient of the x squared term is 1. If the leading coefficient is not 1, we can just divide by the leading coefficient as our first step. The key to using the square root method is to start by dividing the coefficient of x by 2. I think it also helps to write things as x squared plus bx equals c, so I want all of my x terms on one side and all my numbers on the other. Once I have the b over 2, I'm going to square this number and add it to both sides of the equation. That means I'll have x squared plus bx plus b over 2 squared equals c plus b over 2 squared. In math, whatever we do to one side, we always do to the other. So let's give it a try and see if we can use the process. I'm going to start with x squared plus 10x minus 3 equals 0. I'm going to move the 3 to the right side, so I'm going to have x squared plus 10x. I'm going to leave myself some room and put 3 on the right. Then I'm going to take the 10, the number in front of the x. I'm going to divide it by 2, and I'm going to square it. Because I added it on the left, I need to do the same thing on the right. So this says I have x squared plus 10x plus 10 over 2 is 5. 5 squared is 25. That's equal to 3 plus, I have the same 10 over 2 is 5. 5 squared is 25 on the right. So let's write that a little better. X squared plus 10x plus 25 equals 3 plus 25 is 28. So I'm not doing any tricks in this video. We're going to do it the long way, we're going to do factoring, and we're going to see how the square root method works instead of trying to force ourselves to use this method. So the x squared plus 10x plus 25, I can think, well, what are my factors of 25 that give me 10? So I can say factors of 25 are 5 and 5. When I add them together, it gives me 10, so I have x plus 5, and that's equal to 28. Notice x plus 5 and x plus 5 are the same, so I can write that as x plus 5 squared equals 28. This is where the square root method comes in. Now that I've forced this to be a perfect square, I can take the square root. And when you look at it and think, okay, the left side is a perfect square and the right side is not, that's okay. We only need the left side, the part with the x, to be the perfect square. I'm going to take the square root of the left, I take the square root of the right. On the left, I have x plus 5. On the right, make sure you write plus or minus, and then the square root of 28. We need that plus or minus to give us our two solutions, which we know we always have when we're solving a quadratic. When I look at 28, I can think of 28 as being 4 times 7. So I want to think about when I take the square root of 4 times 7, I really have the square root of 4 times the square root of 7, which is 2 square root of 7. So that reduces my radical a little bit. Now I have x plus 5 equals plus or minus 2 square root of 7. The last thing I need to do is move over the 5 from the left, put it on the right side. When I'm moving it over, it goes from positive to negative, so I have x equals negative 5 plus or minus 2 square root of 7. Oftentimes when you enter this in the homework or a quiz or somewhere that you have to type in the answer, you may not be able to do the plus or minus, so I want you to think that my answers are negative 5 plus 2 times the square root of 7 and negative 5 minus 2 times the square root of 7. Let's try that again. This time I have 3x squared minus 18x plus 30 equals 0. Seeing that 3 in front of the x squared says let's go ahead and divide everything by 3. So I'm going to do that 4 times. Everything that I have in the equation is going to get divided by 3. That says I have x squared minus 6x plus 10 equals 0. I do this to show you that this is not a factorable equation. I have 10 and I'm trying to get to negative 6. Well, my factors of 10 are 1 and 10. That would give me 11. 2 and 5 would give me 7, but I don't have factors that give me a negative 6, so I'm going to use the square root method. Step number 1 is I'm going to move this 10 to the right side. So I have x squared minus 6x. I'm going to leave some space, and I'm going to write negative 10 on the right. Then I'm going to take the coefficient of x. Make sure you pay attention to the sign. When I'm adding, I have negative 6 over 2 squared. Now I have negative 6 over 2 squared on the right as well. This is x squared minus 6x plus negative 6 over 2 is negative 3. Negative 3 squared is 9. On the right side, I have negative 10 plus the same 9 I had on the left. The number that I add on the left and the number I add on the right will always be the same because they both come from b over 2 squared. Now I look at 9 and I think, what factors of 9 give me negative 6? I know both of my factors are going to be negative because of the plus sign. So I have x minus and x minus. Factors of 9 that give me 6 are 3 and 3. On the right side, I can simplify negative 10 plus 9 to be negative 1. Once again, I have this duplicate factor on the left, x minus 3 and x minus 3. Let's write that as x minus 3 squared. On the right, I have my negative 1. I'm going to take the square root of the left. I'll take the square root of the right. This says x minus 3 equals plus or minus. The square root of negative 1 by definition is I, so I'm just going to write that as the I, and I drop the square root of negative 1. To finish, I need to move the 3 to the right, so I have x equals 3 plus or minus I, which I would want to enter as 3 plus I, comma, 3 minus I when I do the homework or quiz. So let's try one last problem to make sure we understand the process. I have x squared plus 18x minus 141 equals 0. We're going to skip trying to factor it, and we're just going to say, let's go ahead and use the square root method. I have x squared plus 18x. You know you're going to move the 141 to the right. Then I come back to the x term, which has an 18 as the coefficient, and I divide it by 2 and I square it. Do the same thing on the right, 18 over 2, and I square it. This gives me x squared plus 18x plus 18 over 2 is 9. 9 squared is 81. So that says on the right side, I'll have 141 plus 81. Now I look for factors of 81 that give me 18. That'll be x plus 9 times x plus 9. On the right side, 141 plus 81 is 222. So like our last two problems, I have this duplicated factor, which I'm going to write as a square. So x plus 9 squared equals 222. I take the square root of the left, I take the square root of the right. The left side gives me x plus 9. The right side, I have plus or minus the square root of 222. You could spend some time looking at 222 if you want. Hopefully you see I can divide by 2, which gives me 111. Well then 111 equals 3, so that says I could divide by 3, which gives me 37. 37 is prime. So I have 3 factors of 222, but none of them are duplicated. There's nothing I can do to reduce this number. So because of that, the only thing left to do is to move over the 9. Now I have x is equal to negative 9 plus or minus the square root of 222. So I hope that helps to see the square root method in a little different way, where I didn't jump and do any extra steps. We took each step one thing at a time, did our factoring on our own, saw that things are perfect squared, and then take the square root to find our two answers.